So now we look at friction. And we all know what is friction. It's when two objects rub against each other, then there is a resistive force that tends to stop or slow down the motion or the relative motion between them, and that is friction. So if you have the ground and you have something sitting on it, and if you pull with a small force, then the friction may be enough that it will not move. So let's also make the mg, which is the weight of the object, and the normal force, which would in this case be equal to mg. Now we apply a small force, and the friction will always tend to oppose the motion, and if friction is large enough, it acts backwards and it's equal to the force, and it prevents it from moving. So you increase the force, and what happens is that the friction increases, and it's still exactly equal to the force, and the thing still does not move. So let's suppose it requires this much force for it to start moving. So as you keep on increasing the force, make the force bigger and bigger and bigger, the friction automatically gets bigger and bigger and bigger until the force reaches a value that the friction can no longer get bigger than this number. That is the maximum friction that can exist between these two objects, between the object and the floor. And we can write that as, well, it's static friction because it's not moving yet, and max because that's the maximum static friction that we can have. Once the force exceeds this value and becomes bigger than that, well, now the force is bigger by the maximum possible friction, and therefore when we add the friction and the force, F and friction, there's a net force in the positive direction, and the whole thing starts moving forward. So if you look at this on a force and Fs diagram, which is this, the friction, and there are two kinds of friction. So one of them is Fs, which is the static friction, static when the two surfaces are not in relative motion. That's static friction. So as the force keeps increasing, the friction force keeps increasing. So you keep increasing the force, the friction keeps getting bigger. And this is a 45-degree line, which means that at any value of F, the value of friction is equal to the value of F. And this keeps going until it reaches that value, which was the maximum possible value. So let's suppose this is the maximum possible value. So this is written as Fs max, and at that point the force will be, well, equal to that because this is a 45-degree line. And then if you increase the force further, the friction cannot increase further, and so the applied force becomes bigger than the force pulling it back, and the thing starts to move. As soon as the surfaces are in relative motion, now we have sliding. The object is sliding over it, and as soon as that happens, the nature of friction itself changes. So we have two kinds of friction. Nature of friction is either static, which is so long as it's not moving, or it's kinetic, when the two surfaces are slipping with respect to each other. So this is when there is no motion, and this is when there is motion. So it's well, motion may not be the right word, it's slipping. The surfaces are in relative motion with respect to each other. Okay, so the two surfaces are in relative motion. So you would have friction if this is moving to the right or this is moving, so whenever the two have relative motion. As soon as that happens, the magnitude of the friction, the magnitude or the value of this force decreases. So the kinetic friction under the same conditions is less then the static maximum friction. So this is the static maximum, and the kinetic is almost constant, does not depend on the force, but it's less than this. So this instantly decreases and becomes all more or less constant. So this is Fk, K for kinetic. So the kinetic friction is about 20 to 25% smaller than the maximum static friction. Now, what is the value of friction? What is the value of this point or at any other point? And what is the value of the friction at this point? We know that the friction, or let's say the force of friction, which is simply friction, equals mu times n, where mu is the coefficient of friction. And well, because we have two kinds of friction, so we have two kinds of mu. We have mu s, which is the coefficient of static friction, and we have mu k, which is the coefficient of kinetic friction. So we have two kinds of friction. So we will write this like a mu s is mu sn, sorry, fs is mu sn, and fk is mu k n. Now here we should say it's less than or equal to, and I'll come to why we should say that. So let's say in this particular example, in this case, what will be the value of the maximum possible friction? What is the value of this? So let's suppose that we have this situation. We have a mass m, so this becomes mg, this becomes the normal force, and we are pulling this way. So what is the maximum static friction? And we say that the maximum static friction is mu s n. The mu s is a value that's between 0 and 1. So the more friction we have, the more is the coefficient of static friction. So we'll get the value of mu s, and the value of n, well, in this case it's equal to mg, but it's better if we first write the sum of forces in the y direction, set them to 0. In the positive y we have n, in the negative y we have mg equals 0, and therefore n equals mg, and it will not always be this, so it's always better to write this equation mg. So this becomes the maximum possible friction, and if the pulling force is more than that, well, then what happens? So let's assume that this force is bigger than that. Then we write the sum of forces in the x direction equals max. The force pulling to the right is F. The force pulling to the left is Fs max, and that will give us this mass times the acceleration in the x direction, and it will start accelerating towards that direction.